Welcome to Part 2 of using the statistical distributions. We begin by clicking on the appropriate button from the home screen, which brings us to the Statistical Distributions main menu. I'd like to run 3 of these. First binomial, then exponential, and then lastly inverse normal. So to begin with, I click on the binomial PDF. Recall, PDF is for a point distribution. In other words, I'm looking for the probability of an exact number of successes. So let's just say we have 10 trials where the probability for success on any given trial is 25%, and we're trying to find the probability of exactly 2 success. We click calculate. We see that the probability of exactly 2 successes is 0.2815. There is a help provided. You simply click on show help. I give the formula in case you want to work this out by hand, and a verbal description that will help you with the formula and the distribution. Next, I would like to work the binomial CDF. Now this is for the cumulative density function, where we're looking for a cumulative number of successes. So if we still have 10 trials and we still have a 25% chance of success, and we enter a 2, this would mean we're trying to find the number of successes of 0, 1, or 2. Any of those would be considered a success. That's why it says the maximum number of success, x, is 2. So that would include a 0 success, 1 success, or 2 success. We click calculate, and you notice that the probability is quite a bit higher now. It's 0.5255. Again, there is a help provided. About the only difference is you see a summation symbol here, which means you have to add them together. So you would add from 0 up to 2. So you'd have to work this for 0, then you'd have to add working it for 1, then you'd have to add working it for 2. The next distribution I'd like to look at is a continuous distribution, the exponential distribution. For continuous distributions, we usually enter a lower bound, an upper bound, and a mean. So let's just say that we're trying to find the area under the curve, or the probability for success, that a value will fall between 2 and 6 if we know the mean is 4. I just made these numbers up. Of course, it'll change for your problem. I click calculate, and I see that the probability for success, or the area under the curve, is 0.3834. If I want to see the graph, I click graph. I can see the display. It's shaded between 2 and 6 because that's the interval I asked for, and it gives me the area under the curve, which is the probability for success. Again, even for the continuous distributions, I've provided a help. You can click on show help. I give the formula, and I give a verbal description of how to use the formula and how to use the distribution. Lastly, I said I would like to look at the inverse normal distribution. That's inverse Z here. So I click on inverse Z. This is where we go to enter the percentile, and the actual value will be returned. So for example, the problem would sound like this. What value separates the upper 10% of the data if the mean is 100 and the deviation is 10? So we're trying to separate the upper 10% of data from the rest of the data. Well, the application needs to know the percentile. So if it's the upper 10%, then we must be at the 90 percentile. Remember, percentile reads from the left. So if I'm trying to find the upper 10%, that means 90% is to the left. If the mean was 100 and the deviation is 10, I fill in those values. I click calculate, and I can see that the actual number that separates the upper 10% from the lower 90% is the value 112.816. There is a help provided, so you don't have to remember all this at one time. I did provide help for you on all of these screens. And that ends your session on statistical distributions, part 2.